Next problem. A rectangular beam 300 mm deep is simply supported over a span of 4 meter. What UDL per meter the beam may carry if the bending stress is not to exceed 120 Newton per mm square. So given moment of inertia I equal to 80 into 10 power 6 mm power 4. So first of all you write down the given data first. Depth of the beam D equal to 300 mm. Maximum bending stress F max equal to 120 Newton per mm square, and moment of inertia I equal to 80 into 10 power 6 mm power 4. Length of the beam equal to 4 meter, that is 4000 mm. So we find the intensity of the UDL spread over the entire span W kilonewton per meter. Just we find the intensity of the UDL. The solution is distance of extreme layer from the neutral axis, that is y max equal to d by 2. The depth equal to 300 mm divided by 2 equal to 150 mm. In case of simply supported beam subjected to a UDL, maximum bending moment M equal to WL square divided by 8. Maximum bending moment M equal to WL square divided by 8. We put a W into 4000 square divided by 2, 8. Answer is 2 into 10 power 6 W Newton meter. So answer in terms of W. So we know that M by I equal to F max by Y max. So to flexural formula, 2 into 10 power 6 into W divided by 80 into 10 power 6, the 120 divided by 150. So here W equal to 120 into 80 into 10 power 6 divided by 150 into 2 into 10 power 6, that is 32 Newton per mm. Our answer is 32 kilonewton per meter. So finally you write down the result. The number 1, the intensity of the UDL spread over the entire span W equal to 32 kilonewton per meter. Next problem. A test beam of square section 25 mm into 25 mm is broken by a transverse load of 750 Newton at the center of the span 1 meter. Using factor of safety of 4, calculate the safe UDL for a beam of 120 mm width and 300 mm depth freely supported over a span of 5 meter. So first test beam, that is in cross section square, that will be broken by 750 mm central load. From this we have to make the another one beam with the width and 300 mm depth. So this is they have asked. So now you see the number 1 test beam. Consider test beam. Given data, first write down the test beam is 1 meter long and 750 mm central load. The cross sections are square 25 mm squares. So width of the beam B equal to 25 mm and depth of the beam BD equal to 25 mm also. Length of the beam L equal to 1 meter, that is 1000 mm. To find the maximum bending stress induced F max, maximum bending stress due to 750 mm load, that is in Newton per mm square. The solution is, you know, the F max by Y, M by I equal to Y max. Distance of extreme layer from the neutral axis. First you find the moment of inertia I equal to BD cubed by 12, that is 25 into 25 cubed divided by 12 equal to 3255 mm power 4. Here Ymax distance of extreme layer from the neutral axis Ymax equal to d by 2, 25 divided by 2, 12.5. Maximum in case of simply supported beam subjected to a point load, maximum bending moment M equal to WL divided by 4. So simply supported beam, point load, the maximum bending moment M equal to WL divided by 4. 750 into 1000 divided by 4. Answer is 187500 Newton mm. So we know that M by F max, M by I equal to F max by Y max. So F max equal to M by I equal to Y max equal to 187 by 000 into 12.5 divided by 32552. Answer is 72 Newton per mm square. So test beam, the F max equal to 72 Newton per mm square. In actual beam, given the width of the beam B equal to 120 mm and depth equal to 300 mm, length 5 meter, factor of safety consider as 4. So to find the safe UDL spread over the entire span, that is W kilonewton per meter. Solution is working stress. Just we find out the working stress first. Working stress equal to maximum stress divided by factor of safety. So our working stress in previous case is 72 Newton per mm square. So factor of safety 4. Just we got 18 Newton per mm square is our working stress. Moment of inertia I equal to BD cubed by 12. So just you put 120 into 300 cube divided by 2, 2.7 into 10 power 8 mm power 4. Distance of extreme layer Y max, so 300 divided by 2 equal to 150 mm. In case of simply supported beam subjected to a uniformly distributed load, the maximum bending moment M, that is equal to WL square divided by 8. So simply supported beams UDL maximum bending moment M equal to WL square divided by 8. So W into 5000 square divided by 8. Answer is 3.125 into 10 power 6 in terms of W. The answer in terms of W. So we know that a flexural equation M by E equal to F max divided by Y max. So just you put all the data, 3.15 into 10 power 6 into W divided by 2.7 into 10 power 8. The answer is 18 divided by 150. This will be equal to this, and W, from this we got W equal to 10.368 Newton per mm. By in case of kilonewton, 10.368 kilonewton per mm. So finally we write down the result. The safe UDL spread over the entire span W equal to 10.368 kilonewton per meter.